Welcome back, folks. So in this video we are going to take a look at how you can use a graph to find the domain and range. So if you haven't already, I urge you to watch the previous video to just get a sense of what the domain and range is. But in this video, let's just take a crack at these graphs. So first off, notice here, which of these A, B, C, D, E, F are functions versus not. That doesn't actually affect our answer for the domain and range, but I think why not ask the question since we're here. So you should pause the video and take a look at these. Okay, so I'm going to assume that you did pause the video and think for a second, hey, which of these are functions and which are not? Well, remember, the function, for every input, or x, there's only one y. An example of that would be this one, c, here. Or this one, if I take a look here, oh hey, at x equals -2, there's only one point that's just right there. And at x equals 1, there's only one point, which is right there. And so yeah, every input, x, has only one output, y. So this one is a function. This is a function. Okay, but if I look at something like e, hey, when I go to, let's see, x equals 2, okay, that checks out, because yeah, there's only one y value for x equals 2. But hang on a second. If I see here, at x equals +3, so right here, this is x equals 3, there's 3 points right here. There's 3 different y values. This right here is y equals, was that y equals 2? Right there, that's y equals 0. And right there, that's at y equals -2. And so, hey, on this function machine, or sorry, this relation machine anyway, there is an input, x equals 3, that spits out 3 different y values, 3 different outputs. And so if you think back to the soda machine example, or snacky machine example rather, this is not a function because you can't really predict what's going to happen if you give it x equals 3. So you really only need to find one input that has a bunch of different outputs. That tells you it is not a function. So this one would be not a function. You could follow the same argument for all the other ones, and you should see that this one is also not a function. Not a function. Alrighty, so I'm going to clean this up because that's not actually what the question is asking, but I just wanted to, take a quick second and review what is a function and not. Okay, so we are back taking a look at, oh, actually, hang on. I wasn't actually sure if we were recording, but I think we are now. Okay, so let's figure out our domain and range. So I'll do my domain in red, and we'll do our range in blue. So here's a way that some people like to see the domain and range is they basically like to draw a box around the function, or a square around the function. And here's what I mean by that. Well, the domain is all the possible x values that the graph hits, x values. And the range is the y values. And so if I want to find the x values, well, you're basically putting a barrier around how far to the left and how far to the right the graph goes. And you could basically just bring these walls in until you first touch the graph. So this one on the left here, and again, these are straight vertical. You're not going to hit the graph until we get right here. And I would usually draw a dotted line here. And similarly, on the right side, you can hit the graph there. And so the question is now, where are those lines, those walls? This one right here, I believe, if I have reading my graph correctly, this should say, this is happening at x equals -3. And this right here, that's happening at x equals, let's clean this up, I apologize. This is happening at x equals +3. And so our range, or sorry, not our range, our domain, because we're looking at the x values here, our domain for this one, where am I going to put this? Our domain And to write this, we just put D, and then this is a little colon. I'm not going to put an equal sign here. The domain is all the x values, x's, or I'll say x's to kind of abbreviate it, from -3 to 3. And to be really clear, you could say inclusive if you're not confident, because this does include -3 and 3. Or you could say it like so, or -3 is less than or equal to x, which is less than or equal to +3. That's one way to say that as well. Alrighty. Let us now take a look at the range, and the range can be done in this, again, similar fashion. So I think I said I'll use blue. So again, the range is taking a look at the y values. And so, well, the lowest y value is, I'm going to take the same idea with the walls here, or except this time it's a floor and a ceiling rather, I guess. Hits right there, and I believe that's at y equals -3. And on the very tippy, the very tippy top here, that's happening at y equals 3 as well. And if you can see, this looks like a circle centered at the origins, so it kind of makes sense that its domain and range are pretty much the same thing. And so for my range here, I'm going to say my y values are greater than or equal to -3, and then less than or equal to +3. Okay. I'm not going to go through all of these here, but I will just go through some. Okay, so we're going to take a look at, let's look at B. We're going to do A, B, and then we're going to do, we'll do E. Alrighty. So with B is an interesting one because, well, if I went with the wall example, so for the domain, I'm going to draw on red lines here. And I kind of close them in until I'm just barely touching the graph. But here's something to be really careful of, folks. Notice that this graph's got arrows on it. I'm going to just make those really big and obvious. It has arrows, which means it continues on in the pattern that it is, that you see anyway. And so, well, this one's a linear function, and it is indeed a function. And it's going off to the up and to the right forever, and also down and to the left forever. So that means I'm basically gonna have to pull these red lines, these red walls, outward, back to positive and negative infinity. But since the graph keeps going in both directions forever, so are the red walls. And so actually, it looks like the x values that it's gonna hit are pretty much every single x value from negative infinity to positive infinity. And we can also see this similarly for the range. My wall, my blue floor and ceiling are going to have to kind of encapsulate the graph. They're going to have to go up all the way and then down all the way. And so this tells us that our range, or sorry, let's start with domain. Our domain is going to be all real numbers from positive infinity to negative infinity. Or sorry, if we go left to right, negative infinity to positive infinity. And likewise, our range is also all real numbers. Notice that B and C, these two graphs, look almost exactly the same, except that C does not go on forever because it's got these two endpoints. By the way, another fancy way to say all x could be any real number, here's a fancy schmancy way of saying it, or x, this is the Greek letter epsilon, it looks like a little curvy e, and then real numbers is r. So this is basically a letter r with another line through it to make it look bold. Let me write that a little better. This would be a fancy way of saying it if you want to be fancy again. And likewise for the range. Or y can be, but I'll take either one of these. Either one of these is totally fine. And let's take a look at E now. E is going to be just like A here. where, let's see, it looks like I can draw a box around the graph right here, and that looks to be at x equals 2, and over here it looks like this is x equals 4. So we know my domain is going to be, let's see, from -2, and then the x's are, so between -2 and 4, including -2 and 4. And likewise, our range, let's see, the bottom of the range here is going to be at -3, y equals -3. And the top is going to be right around here, and that's going to be y equals, I think, +2. So our range is going to be our y's. So we always want to say what the output is. In this case, it's y, but it might be a different letter depending on the situation. We're going from -3 to 2. I just want you to be really careful of one more thing here. I've seen people do things like this where for the range, they'll say that y is, how would I say it? From 2 to, well, they might do something like this because I have seen this. Sorry about that pause. I had to kind of really think about how I've seen this in the past, but I've seen stuff like this. So 2 like that, and I kind of get what you're saying, because, well, I get what you're saying because I've seen this a lot if you wrote this, but it's technically wrong because it does not actually make sense. Because when you say this, like if I was to say this part in words, this thing in green here, or in blues rather, right here, if I said it in words, I would say that y is greater than, greater than or equal to -3, and also less than or equal to 2, right? The part that I'm getting at is this and part, because if I use that same logic and translate this to plain old English, this would say y is greater than or equal to -3, like you said before. And because this is like one big sentence here, so they go together. And greater than or equal to 2, +2. But because of where this goes on the number line, if we look at the number line here, like here's -3, greater than or equal to would be that way, and then if here's 2 and 0 somewhere in the middle, then like these arrows, they all just kind of go that way. This doesn't really make sense, because what our range is supposed to be is this, all the y values between these folks. If this number line confused you, don't worry too much about this, but we want to avoid doing this. So when we're doing our inequalities, we want to really make sure that our alligators are correct. Okay. All right. So I'm not going to go through the rest of them, C, D, and F, but you should try them on your own, and I'm gonna put up here in a second just the answers for C, D, and F. Okie dokie. So I put up the answers here for C, D, and F. It's a little crowded here, so for C, they're right here in yellow. For F, especially around F, it's a little crowded. They're right there. And for D, well, they're right there. That one's pretty easy to see. Just a tip here. For me, I try to lay out the inequalities in order from smallest to greatest from left to right. And here's what I mean by that. So for C, and this will help with this, dealing with this alligator issue that I was talking about a couple seconds ago. When I write a domain, so the smallest possible x value is -2, and so I'll put that first. The greatest possible x value is 4, and so that goes on the far right. And then the x, well, it could be anything in between, so that's why it's in the middle. And also including, so don't forget the or equals to part underneath the alligators. For the range, likewise, you're starting from -4 because -4 is the smallest, right? The most negative. And then it ends at 2, so that's why 2 is on the right. And then y is in the middle. If we look at f, just a second here, f, again, it starts off, like the graph actually kind of has a starting point here. It starts off at 0, 3, right here. And this is a case where there's an endpoint on the left for x because it starts off at 0, and then it just keeps going because, again, the arrow implies it's going to keep going, going, going. So that's why the domain is, I say 0 is less than x. I could say 0 is greater than x, or greater than, sorry, excuse me. I could say that 0, sorry, our domain for f is 0 is less than or equal to x. Alternatively, technically, this is exactly the same, or x greater than or equal to 0. These are exactly the same. But again, it helps me just kind of keep my head on straight when I put the smallest one first. And that's why for the y, for the range, I said 3 is less than or equal to y. But again, it totally would have been fair and right to say this. And then there's D here on the bottom left. So hopefully this helped you out. If I give you any type of crazy spicy graph, you should be able to find the domain and range. All right. One last thing that didn't come up here, actually, it's totally possible that there's holes in the middle of your graph, and we'll tackle some of those in class together when we see them. So hopefully domain and range from a graph is something that you can do on your own now. I'll catch you in the next video, folks. Thanks for watching.